Article 220.87 of the National Electrical Code, or NEC, provides guidelines for determining the existing electrical demand of a building. This is particularly useful when adding new equipment, services, generators, or transfer switches to an existing building, especially when historical power consumption data is available. This article allows engineers and designers to utilize actual historical data to determine the existing load rather than relying solely on calculated loads, which can sometimes lead to oversizing equipment. To apply Article 220.87, you must meet 3 specific conditions. If you can satisfy all 3 requirements, you can leverage the provisions of this article to avoid unnecessarily increasing the service size for new building services, generators, and transfer switches. The first condition is that the existing building is not being enlarged or structurally altered. This means that the physical footprint and structural components of the building should remain largely unchanged. The intent here is to ensure that the historical load data accurately reflects the current building configuration. If the building has undergone significant structural modifications or expansions, the historical data may no longer be representative of the present load profile. Structural alterations would include changes to the building's frame, walls, roof, or foundation. Minor interior modifications such as demolishing or erecting non-load-bearing walls or interior remodels generally do not violate this condition, as these types of changes do not typically have a significant impact on the overall electrical load of the building. The second condition stipulates that the electrical load is not increased. This condition is crucial as it ensures that the existing historical data is representative of the current and future load demand. To verify that the electrical load has not increased, you can utilize power company billing data for the previous 2 years. Analyzing the billing data will provide a clear picture of the building's historical energy consumption patterns. Look for trends and patterns in the data to determine if there has been a consistent increase in the electrical load over time. If the billing data reveals a consistent increase in energy consumption, it may indicate that the electrical load has increased and that Article 220.87 may not be applicable. Conversely, if the billing data shows relatively stable energy consumption, it supports the argument that the electrical load has not increased and that Article 220.87 can be applied. It's important to consider any potential changes in occupancy or equipment usage that may have occurred during the period covered by the billing data. For example, if the building has undergone a change in occupancy, such as a conversion from office space to retail space, it may impact the electrical load even if the square footage remains the same. Similarly, if new high-energy consuming equipment has been added to the building, it can also impact the electrical load. The third condition states that the existing service is adequate for the addition. This condition requires a careful review of the load calculations to determine if the existing service has sufficient capacity to accommodate the new generator and transfer switch. In many cases, conservative load calculations may result in an overestimation of the required service capacity. By carefully reviewing the load calculations and considering the actual historical load data, it may be possible to demonstrate that the existing service has sufficient capacity for the new equipment. The term adequate in this context means that the existing service has enough capacity to safely and reliably supply the existing load plus the additional load imposed by the new generator and transfer switch, without exceeding the service's ampacity rating. Furthermore, the existing service should also have sufficient capacity to handle any future load growth that may occur. To verify that the existing service is adequate, perform a comprehensive load calculation that takes into account the existing load, the new load from the generator and transfer switch, and any future load growth. Compare the total calculated load to the ampacity rating of the existing service. If the total calculated load is less than the ampacity rating of the existing service, it indicates that the existing service is adequate. If the total calculated load exceeds the ampacity rating of the existing service, it indicates that the existing service is not adequate and an upgrade may be required. When evaluating the adequacy of the existing service, it's essential to consider various factors, including the diversity factor, demand factor, and power factor. The diversity factor accounts for the fact that not all electrical equipment in the building will be operating at its maximum load simultaneously. The demand factor accounts for the fact that the actual load in the electrical system may be less than the calculated load due to various factors, such as equipment cycling and usage patterns. The power factor reflects the efficiency of the electrical system. A lower power factor results in higher current flow, which can reduce the capacity of the existing service. In addition to meeting the three conditions outlined in Article 220.87, it's crucial to consult with local electrical codes and regulations to ensure compliance. Local codes may have additional requirements or restrictions that must be followed. It's also recommended to consult with a qualified electrical engineer or contractor to perform the load calculations and verify the adequacy of the existing service. These professionals have the expertise and experience to accurately assess the electrical system and ensure compliance with all applicable codes and regulations. In summary, Article 220.87 provides a valuable tool for determining the existing electrical demand of a building, especially when historical power consumption data is available. By meeting the three conditions outlined in the article, you can leverage the provisions of this article to avoid unnecessarily increasing the service size for new building services, generators, and transfer switches. However, it's essential to carefully review the load calculations, consult with local codes and regulations, and consult with a qualified electrical engineer or contractor to ensure compliance and safety. Using this approach will ensure an accurate and compliant electrical system design. Article 220.87 provides an alternative method for determining feeder and service loads. Instead of relying solely on calculated loads based on the connected equipment, this section allows you to use actual recorded maximum demand to determine the existing load. This can be particularly beneficial when adding new equipment or expanding an existing facility, as it can often result in a more accurate assessment of the actual load requirements. The fundamental idea behind Article 220.87 is that the actual maximum demand of an existing installation, as evidenced by historical billing data or demand measurements, is a reliable indicator of its ongoing electrical needs. This approach can be more realistic than simply adding up the nameplate ratings of all connected equipment, which often overestimates the actual load due to diversity and usage patterns. However, it's crucial to understand the specific conditions and limitations outlined in Article 220.87 to ensure its proper application. Firstly, Article 220.87 specifies that the calculated load must not be less than the largest of several factors. These factors include the sum of 125% of the nameplate rating of the largest motor plus the sum of the other loads, or 100% of the continuous load plus 100% of the non-continuous load. These requirements ensure that the calculated load adequately accounts for the potential maximum demand of the installation. Secondly, Article 220.87b outlines the conditions under which you can use the maximum demand data to determine the existing load. The three key conditions are as follows. The existing installation must have been in operation for at least 1 year. The maximum demand data must be based on a 15-minute interval, and the maximum demand data must be obtained from a reliable source such as utility billing records or demand measurements. These conditions ensure that the maximum demand data is representative of the typical operating conditions of the installation and that it is obtained from a reliable source. Thirdly, Article 220.87c provides guidance on how to apply the maximum demand data. You can use the maximum demand data to determine the existing load for the purpose of calculating the required size of feeders, services, and overcurrent protection devices. However, it's important to note that the maximum demand data must be adjusted to account for any known changes in the load or operating conditions of the installation. For example, if you are adding new equipment or increasing the operating IOs of existing equipment, you must adjust the maximum demand data to reflect these changes. Now let's discuss how to apply Article 220.87 in practice. The first step is to gather the necessary data. This includes the nameplate ratings of all connected equipment, the utility billing records for the past year, and any available demand measurements. The second step is to calculate the existing load using the conventional methods outlined in Article 220. You will need to determine the sum of 125% of the nameplate rating of the largest motor plus the sum of the other loads, and 100% of the continuous load plus 100% of the non-continuous load. The third step is to analyze the utility billing records and demand measurements to determine the maximum demand of the installation. You will need to identify the highest 15-minute demand recorded during the past year. The fourth step is to compare the calculated load and the maximum demand. If the maximum demand is lower than the calculated load, you can use the maximum demand to determine the existing load. However, you must ensure that the maximum demand data is adjusted to account for any known changes in the load or operating conditions of the installation. Finally, you can use the existing load to calculate the required size of feeders, services, and overcurrent protection devices. Remember to consult with a qualified electrical engineer to ensure that you are applying Article 220.87 correctly and that your electrical system is safe and compliant. Article 220.87 is a valuable tool that can help you optimize the design of electrical systems and avoid oversizing equipment. By understanding the specific conditions and limitations of this article, you can ensure that your electrical system is both safe and efficient. In addition to the points previously discussed, there are several other important considerations when applying Article 220.87. Firstly, it is crucial to accurately identify and classify all loads within the existing building. This includes distinguishing between continuous and non-continuous loads, as well as identifying any loads that may be subject to demand factors or diversity factors. Continuous loads are those that operate for 3 hours or more at a time, while non-continuous loads operate for less than 3 hours. Demand factors and diversity factors are used to reduce the calculated load to account for the fact that not all loads will be operating at their maximum demand simultaneously. Secondly, it is important to carefully evaluate the reliability and accuracy of the available maximum demand data. Utility billing records can be a valuable source of information, but it is important to verify that the data is complete and accurate. Demand measurements can also be useful, but it is important to ensure that the measurements are taken over a sufficient period of time and that they accurately reflect the typical operating conditions of the installation. Thirdly, it is essential to consider any potential future changes in the load or operating conditions of the installation. If there are plans to add new equipment or increase the operating hours of existing equipment, the maximum demand data must be adjusted to reflect these changes. It is also important to consider any potential changes in occupancy or usage patterns that may impact the electrical load. Fourthly, it is important to document all assumptions and calculations made when applying Article 220.87. This documentation should include a detailed description of the existing loads, the maximum demand data used, the adjustments made to account for future changes, and the calculated size of feeders, services, and overcurrent protection devices. This documentation will be helpful for future reference and can also be used to demonstrate compliance with the NEC to electrical inspectors and other stakeholders. The NEC provides specific guidelines for calculating the ampacity of conductors and the size of overcurrent protection devices. It is crucial to follow these guidelines carefully to ensure that the electrical system is safe and compliant. The NEC also includes requirements for grounding and bonding, which are essential for preventing electrical shock hazards. In addition to the NEC, local electrical codes and regulations may also apply. It is important to consult with the local electrical inspector to determine any additional requirements that must be followed. In conclusion, applying Article 220.87 requires a thorough understanding of the NEC and careful consideration of all relevant factors. By following the guidelines outlined in this article and consulting with a qualified electrical engineer, you can ensure that your electrical system is safe, efficient, and compliant. One aspect of Article 220.87 is that it does not permit the use of calculated loads to be less than the actual connected load. This means that even if the historical billing data suggests a lower demand, the electrical system must still be designed to handle the full potential load of all connected equipment. This is a critical safety requirement to prevent overloading and potential fire hazards. When evaluating historical billing data, it's also important to consider any seasonal variations in energy consumption. For example, a building with significant air conditioning loads may have higher energy consumption during the summer months. The maximum demand data used for calculation should reflect the highest demand recorded during the year, regardless of the season. Another important consideration is the impact of power factor on the calculated load. Power factor is a measure of how efficiently electrical power is used. A low power factor can result in increased current flow and higher energy losses, which can impact the capacity of the electrical system. If the power factor is significantly low, it may be necessary to install power factor correction equipment to improve the efficiency of the electrical system. When applying Article 220.87, it's also essential to consider the coordination of overcurrent protection devices. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. It is crucial to coordinate these devices so that they trip in a coordinated manner, minimizing the impact of a fault on the electrical system. This coordination helps to prevent nuisance tripping and ensures that the electrical system remains reliable. In addition to the technical aspects of applying Article 220.87, it's also important to communicate effectively with the building owner or manager. They can provide valuable insights into the building's operating conditions and any potential future changes. By working together, you can ensure that the electrical system is designed to meet the building's current and future needs. In summary, Article 220.87 provides a flexible and practical approach to determining the existing electrical demand of a building. However, it's essential to apply this article carefully and to consider all relevant factors. By following the guidelines outlined in the NEC and consulting with a qualified electrical engineer, you can ensure that your electrical system is safe, efficient, and compliant. Furthermore, remember to document all assumptions, calculations, and decisions made during the design process. This documentation will serve as a valuable reference for future maintenance, modifications, and inspections. It will also demonstrate your adherence to the NEC and industry best practices. It is often beneficial to create a single-line diagram of the electrical system. A single-line diagram provides a simplified representation of the electrical system, showing the major components and their interconnections. This diagram can be a valuable tool for understanding the system's operation and for troubleshooting any problems. In addition to the single-line diagram, it's also helpful to create a panel schedule. A panel schedule is a detailed listing of all the circuits in an electrical panel, including the connected loads, the wire size, and the overcurrent protection device rating. This schedule can be used to quickly identify the circuit supplying a particular load and to verify that the circuit is properly protected. Consider conducting a load study to gather more detailed information about the building's electrical consumption. A load study involves monitoring the electrical system over a period of time to determine the actual demand and usage patterns. This information can be used to refine the load calculations and to identify any potential areas for energy savings. Also, remember to factor in future expansion plans. While Article 220.87 allows for using existing load data, it's crucial to anticipate any potential increases in electrical demand due to future renovations, new equipment installations, or changes in occupancy. Plan accordingly to ensure that the electrical system can accommodate these future needs without requiring costly upgrades. Moreover, remain updated with changes to the NEC and other relevant standards. Electrical codes and regulations are constantly evolving to reflect new technologies, safety concerns, and best practices. Stay informed about the latest changes to ensure that your electrical designs are always up to date and compliant.